Hi, hello. So, my name is Matheus Gabriel. I'm from the SA team, and today I will talk about the TaurusDB database and how it will help Grupo Matheus to make its operations inside retail more efficient. So, I'll start with a context on how Grupo Matheus is operating inside their own databases, and I'll explain also how TaurusDB makes high availability for MySQL databases, and I'll give a brief demo at the end showing it in practice. Okay, so for those who don't know, Grupo Matheus is nowadays one of the biggest retail customers inside of Brazil, working especially in the north and the northeast regions of Brazil, working with supermarkets, convenience stores, and distribution centers. So especially nowadays, they're trying to enter the e-commerce with their Matheus Mais applications. So, so in the context of this meeting, we initially had an initial meeting to introduce our services for them. So where they highlighted one of the main pain points for them nowadays, especially with that migration to e-commerce, is that their current on-premises MySQL database is suffering from the low performance, especially during peak hours, which is one of the most important parts when you're dealing with the retail. So we decided to schedule this meeting for this demo to show our TaurusDB, which is our MySQL compatible distributed database that can deal with the high scalability, high availability that the retail market needs. So about TaurusDB, TaurusDB is our relational distributed MySQL-based database. It is specially made with cross-AZ and decoupled compute and storage layers to make sure that it can attend high performance and high workload scenarios. So in this case, you can show that we are separate in nodes that work, and we operate with also up to 128 terabytes. So what makes TaurusDB different from other databases is that it works with 4 pillars in mind. So with the high performance, so when we did some benchmarks and compared it to Amazon Aurora, our cluster cross-AZ architecture made it that we had 3 times higher performance than Amazon Aurora. We have the high scalability. Since we're dealing with clusterized workloads, we can scale out in minutes using our architecture. We have the high availability. Since we're dealing with cross-AZ, for example, if one AZ fails, the storage layer, since it's spread across multiple AZs, we are able to get this RPO of 0 and the RTO of minus 10 seconds. And of course, we also employ some security techniques like data encryption with TDE and PITR for data restoration in case of emergency. And also we employ log audits. So this is more of a chronological evolution of enterprises. Like, for example, with Grupo Matheus, we had the before stage where you have an on-premises database that requires complex O&M, slow delivery, and it's generally just more expensive to scale. So a lot of what current businesses are doing is that they're migrating slowly to the cloud, achieving, getting closer to our TaurusDB architecture. So for example, see this on the cloud, we have, for example, an ECS running MySQL, which is easier to provision, but it is more complex to integrate with other services and hard to integrate to all of the infrastructure. And then we have, for example, our cloud native architecture with RDS for MySQL, for example, which integrates with other cloud native services, but it doesn't scale as easy. So in this case, we're talking about TaurusDB. We have our cloud native serverless, which TaurusDB offers both serverless for auto scaling, which deals with automatic auto scaling, and our managed TaurusDB, which has the functionalities of the cluster, but requires more control. So for the architectural inside of TaurusDB, we're dealing with the decoupling of the storage and the compute layers. So for example, if you have SQL nodes dealing with the compute, you can have less overhead in dealing with transfers and operations and queries, while the storage layer under it can deal with the data replication inside the workload. This is one of the key parts that makes the performance so much better, up to 3 times better than, for example, Amazon Aurora, for example. And here's some more comparisons that make with Amazon Aurora that shows that while we offer the same features that Amazon Aurora offers with their database, we also extend critical parts, like for example, the read-write splitting on the performance, which I'll talk about later, makes the performance even better for the cluster. And for example, our architecture makes it easier to scale out. Okay. So here we have some benchmarks made with sysbench that show that TaurusDB makes that 3 times more performance than Aurora. As you can see, we did a test with 25 tables and 25,000 rows. And here we can see that the transfer per second and queries per second were way beyond Amazon Aurora in this case. And for the storage layer, for the highest availability, we do the DFV, with the data function virtualization. So what that does is that it takes the data and spreads it across shards, across multiple AZs. So this storage layer gets connected into our compute nodes, so that if, for example, one AZ fails, the other ones can take over, and you have high availability for your cluster, for example. And since, well, in a normal ECS, MySQL, you have all of that centralized. If that fails, you don't have the availability. And for this storage architecture, we also do with the cost saving. So for example, if you have a hot, frequently accessed data, it goes inside that DFV architecture. Like for example, when you're dealing with promotions and events inside your retails, you're gonna have some products that get frequently accessed inside your shop, in your e-commerce application. So that data is usually inside the hot layer of your cluster. And that specializes in the performance, while the code part is the less frequently accessed data gets into our OBS, which helps with the cost saving and the data storing, which makes it cheaper, and while at the same time offering more performance for your clusters. And also talking about a little bit about our serverless TaurusDB. TaurusDB, it helps with the automatic scaling. So for example, if you're dealing with an application that you're not really sure about how the peaks and the spikes of user interaction, so you use the TaurusDB serverless to make it sure that the cluster can automatically recognize, and in under minutes, it can scale up or scale down when needed. So, and also one important thing to notice is that if you have, for example, a connection to your application and the database, if that scaling happens, the scaling is non-intrusive. So you're not going to get, your application is not going to stop while the TaurusDB serverless is scaling, for example. So in this case, we're talking more about the networking. So here, to deal with concurrent and parallel connections, which is which happens a lot in retail workloads, we deal with this read-write splitting. So for example, you have at least one primary node that deals with all of this traffic, the writes traffic, while the read replicas, the nodes from your cluster, they deal with all of the read, which is the more common traffic inside your database. So you get this read-write splitting works via a proxy that separates this traffic along your cluster, which makes it more highly available and easier to scale. So, for example, if you have a promotion and you need to scale your reading, it is easier to scale out. So one of the most important parts when dealing with database, especially in retail context, is the security. So when you're dealing with security, TaurusDB guarantees that it has at least 15 security certifications, including the CSF and the CSA certifications inside. Okay. So when you have your existing on-premises MySQL database, how do you take all of that and migrate to our TaurusDB database? We have a specialized tool called DRS that is able to do full and incremental migration to our TaurusDB. So for example, if you have a workload that is currently operating and is constantly being updated, you can use an incremental migration to make sure that the DRS constantly captures what changes inside the source database and reflects it on the TaurusDB. So you don't have to interrupt your application to migrate to TaurusDB. And this is just a video demonstration of it happening. But I think I'll just skip it for a second. So this is a benchmark that we did comparing ECS normal MySQL to our TaurusDB. And this is just a print to prove that what we did. And this is a more structured results that we observed that TaurusDB offer more than 2.5 times more performance on queries and transactions, even using the same flavors for the machines here, for example. And also, it's important to notice that TaurusDB is not a new experiment. It is a battle-tested database used across many of our clients. And I've come here to highlight two of them, which are I see that are very close to Grupo Matheus' current needs. So first, we start with Starsplay, which is a media company which serves more than 4 million people across 19 countries. So for example, they had similar pain points. Like for example, they had the poor user experience because of their old database, because they couldn't scale and deal with the high availability and the performance. So when they migrated to TaurusDB, they were able to get close to our RPO of 0 with a 0 downtime and more than 10 times more performance to their database. And another case to highlight is our Daily Food, which is a food company in Middle East. It also had a poor the problem that the database were not trustworthy for their workloads. So for example, you can see here that when they migrated to the TaurusDB, they had 50% faster transactions, which is very important if you're dealing with concurrent and many clients, especially for retail. And I like to end this with a TaurusDB demonstration, show it in practice here quick. So here we have the Huawei Cloud console here. I will just enter the TaurusDB. Yes. Let me. So I can see better. Okay, so I prepared the cluster for show it in practice, but first I'll show how it is created, the TaurusDB. Some of the features that it offers. Okay. So you can select from the yearly, monthly, or pay-per-use, so we can build by hour, depending on the workload that you need. So for example, we have let's see, the TaurusDB. You can either use a cluster, which is the most likely workload that you need for the TaurusDB, or you can use a single workload in case you wanted to do small workloads or do the testing for TaurusDB. You can also configure the type of AZ that you'll be using, but since the cluster uses multiple AZs, we'll probably just use that instead. So the storage type, this is more of a compatibility configuration here. So usually use DL6 storage. So we have also the configuration for our flavors that we can use here for TaurusDB. And most importantly, the nodes. So in this case, if you have, for example, 5 nodes, one of them will be obligatorily the primary node that would deal with the writing traffic. And all the other 4 nodes will be responsible for the read replicas in this case. You can have at most 10 nodes in total for this case. And this is also the part of that I mentioned about the DR, the disaster recovery. That if, for example, if an AZ fails, the TaurusDB will automatically switch over to another region, for example. And this is more of networking configurations that's not important right now. And no, yes, I will not create the TaurusDB right now since it takes some time, since it's a big cluster. I'll just show how you inspect and how you use usually TaurusDB. So this is where you manage the cluster. So for example, you can manage your backups and how do you say make schedule a new backup, and where you can also restore with our PITR restorations. We can also manage accounts and the databases and logs inside our cluster. And I'll just show, most importantly, the interface to interacting with the cluster. So beyond connecting it to the applications directly using the MySQL interface, since it's compatible, you can also use our DAS, or interaction service, that you can use to interact directly with your cluster. Okay. Okay, so in this example, I already prepared a quick database here so that we can show some commands here in the DAS. So here you can also manage all of the databases and tables inside your cluster without using an application like the Beaver, for example. You can see the views, stored procedures, events, triggers, and functions inside your database. And most importantly, you can also do SQL commands here. So I'll just perform a couple just to show that it's working. So for example, I'll do this basic insertion. You can also format your SQL. Okay. Okay, see that it works. It shows exactly what happened and the duration. If it had an error, it would tell in detail what happened. Okay. And also this is a selection, see? Here we can see all of the results from our query quickly. And just one more. And here we have another more complex query for the TaurusDB cluster. So what I'd like to show about the cluster was basically this. Since it's a MySQL cluster, there is the demonstration is kind of simple since it's a database. So I just ended and just go back here. So I'd like to ask if anybody has any questions about the presentation.